So let us start the working, everyone. When the first positive cycle comes in, the diode will become forward biased. The moment diode is forward biased, it is replaced with a short circuit, and you can see that the input signal reaches to the combination of resistance and capacitor. The capacitor, which is initially uncharged, will now start charging. So the capacitor starts charging. For the very first cycle, the capacitor will charge instantaneously towards the peak value of the sinusoidal signal. Now, why capacitor charges instantaneously? That is because the charging is through short circuit diode, which offers zero resistance ideally, or negligibly small resistance, and hence there is no resistance in the path of the charging. So capacitor charges instantaneously. So as the input signal reaches to its peak value, the capacitor voltage will also reach to its peak value. Let me mark the polarity of the voltage across capacitor, and let me call the capacitor voltage as VC. Now comes the very important part, which if you understand the entire working of the envelope detector. When the signal is at its peak value, let me take this peak value as Vm. Vm is the peak value of the first cycle. In that case, my Vc will be equal to Vm. Let me call it Vm1 because that corresponds to the peak value of the first cycle. So right now, Vc is equal to Vm1. Now if Vc is equal to Vm1, in that case, the capacitor is charged to the maximum possible value of that cycle. Now let us see what happens after this. After the signal has reached to its peak value, the signal will now start decreasing. The moment input signal starts decreasing, for that very small time instant, if you observe carefully, the capacitor is charged to Vc, which is right now equal to Vm1. So the cathode voltage, the voltage at the cathode of the diode is Vm1, and voltage at the anode of the diode was Vm1, but now starting to reduce below Vm1. So as the input signal now starts reducing below the peak value, the capacitor is following the input signal. So first input signal will reduce its value, and during that time instant, capacitor will hold the value to Vm1, and you can immediately see that the anode will be at smaller potential compared to cathode, and that will make diode reverse bias. So diode will immediately turn off before capacitor can start following the input signal and can start reduce its values, because now the input signal is reducing. So capacitor cannot reduce its value below Vm1 and follow the input signal because diode turns off. Now when that happens, the capacitor cannot charge further, but you can see there is a closed path available in the form of RC now. So capacitor will now start discharging through resistance R. We have to make sure that the discharging is not as fast as charging. So we will decide the RC time constant in such a way that the discharging takes place very slowly. So you can see the capacitor discharges very slowly, and before it discharges further, the input will go through the entire positive cycle. The negative cycle is anyways blocked because the diode is reverse biased, and when the next positive cycle comes in, the diode cannot still become forward biased because the voltage across capacitor is large compared to the input signal. Only when input signal crosses the voltage across capacitor. Now please remember that the voltage across capacitor after the first discussion will be a value less than Vm1 because the discharge has taken place, but discharge is not so large also. So only when input signal crosses this red point, which corresponds to the last charged value of the capacitor, above this point suddenly the anode voltage will be more compared to the cathode voltage now. And when that happens, the diode will turn on again. So when diode becomes forward biased, the capacitor will again start following the input signal. It will again start charging. So it charges to the peak value of the second cycle. Let me call the peak value of the second cycle as Vm2. So now the voltage at the cathode of the diode becomes Vm2. Immediately after Vm2 is reached, the input cycle will start reducing below Vm2. The moment input cycle start reducing, the anode voltage is less than Vm2 and diode will again become reverse biased. When the diode becomes reverse biased, capacitor will start discharging through resistance R, but we will keep RC time constant to a value such that the discharging is very slow. So capacitor discharges to a very small value it discharges by very small value, so it is now less than Vm2 but not very small. So the input signal goes through the remaining positive cycle, negative cycle, and it comes back to its third positive cycle. Again, when the third positive cycle crosses the capacitor voltage, the diode will turn on and capacitor will again start charging towards the peak value. It charges to Vm3. Once the peak value is passed, the diode is off and the capacitor will discharge through resistance slowly. Again, for the next cycle, it will charge to its peak value because for this small amount, diode is turned on again. And you can see this will continue and we get the voltage across capacitor, which will simply trace the envelope or the peak values of the input signal. Because envelope contains the modulating signal, or the shape of envelope is the shape of the modulating signal, I will see the voltage waveform across capacitor with the same shape as the modulating signal. No doubt there are some high frequency ripples available, which is due to the charging and discharging of capacitor. This can be removed using a filter, and also the envelope you can see will be shifted towards the upper side due to some DC bias added because of the carrier. So we'll have to remove this DC bias and bring down the envelope about the horizontal axis so that it's purely AC modulating signal. So we'll be doing all these changes in the practical circuit, which is a modified diode detector.